Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today's lesson is about Differentiation chapter in paper 3. So I'm going to teach you about one of the subtopics in this chapter. But before I go into the subtopic, I will quickly go through what you need to know in this chapter. So the first thing that you need to know in this chapter is how to differentiate exponential function. And the second thing that you need to know how to differentiate is trigonometry function. The third thing to differentiate in this chapter is ln. Besides that, you need to know about the product rule and the quotient rule. The next equation that you need to know how to differentiate is parametric equation and implicit equation. And one more new function in this chapter that you need to know how to differentiate is inverse tangent. This is something new in the syllabus. So for today, I'm going to focus on parametric equation. So what is parametric equations? Parametric equation is the equation where both the x and the y are given as a function of another variable. We call it parameter. So for example, it can be a parameter t, or it can be another parameter like theta. So when x and y are expressed in terms of another variable, we call it parametric equations. So the differentiation of this kind of function is carried out by using chain rule. So here's a very simple example on how to find out the dy dx when you are provided with parametric equation. So for here, you notice that x is expressed in terms of t, y is also expressed in terms of t. So how are we supposed to find out the dy dx? So we can find out by using chain rule. So the first step here is to differentiate x with respect to t, which is dx dt. I'll get 2t. And then you have to differentiate y with respect to t as well, which means your dy dt is equals to 2. Then to find dy dx, you can find out by using chain rule, which is equals to dy dt times dt dx. So the dy dt here is a 2. dt dx will be 1 over 2t. And therefore, the dy dx will be just equals to 1 over t. So you notice that the dy dx will be in terms of the parameter t. That's how we solve for the parametric equation. So for now, let's go into past question discussion. Let's see how we apply the parametric equations knowledge into this question. Have a look at this question, the question of the year 2014, October-November paper, variance 31. So we are given parametric equations where x is expressed in terms of 1 over cos cube t and y is expressed in terms of tangent cube t, where the t must be in between 0 to pi over 2, which means the angle is in the first quadrant. So for part 1, you are asked to show that dy dx is equals to sine t. So what we need to do here is to find out dx dt and the dy dt, then connect them by using chain rule to find dy dx. So first step, how to differentiate the x. I will just rearrange the x, express x in terms of cos t power -3. then only we start to differentiate it. So dx dt is equals to the negative 3 power, can bring to the front, and then cos t in the bracket remains the same, then the n minus 1. So negative 3 minus 1, you have negative 4. So now only we differentiate the one inside the bracket, which is the cos t. So differentiate cos t, we'll get negative sine t. So here I'll simplify a bit. So it becomes 3 sine t over cos power 4t. That's my dx dt. As for the y, it's expressed in terms of tangent cube t. So I'll write it in this form. Bring out the power so that it's easier to differentiate later. So the dy dx here should be equals to, same step, the power bring down, becomes 3 here, then tangent t to the power of n minus 1, so power 2. So differentiate the one inside the bracket tangent t, we should get secant square t. So dy dt is actually equals to 3 tangent squared t secant squared t. And from here, we find out the dy dx by using chain rule, which is dy dt times the dt dx. dy dt is equals to 3 tangent squared t secant square t times 1 over the dx dt. So it should be upside down. Cos power 4t should be at the upper part, and 3 sine t is at the bottom. And what you are asked to show? You are asked to show dy dx equals to sine t. So you need to simplify this. So tangent square, you split it into sine squared t over cos squared t. Secant square, make it into 1 over cos squared t times cos power 4 over 3 sine t. So you notice that the 3 can be cancelled off. The cos power 2 can be cancelled off with the cos power 4. Sine t cancel off with the sine square at the upper part. Then you are left with only sine t. That's how we show for the part 1. As for the part 2 here, hence means related to part 1. Show that the equation of the tangent to the curve at a point with the parameter t is given by y equals to x sine t minus tangent t. This is what we need to show. And you notice that the equation of the tangent is in terms of the parameter t. So to form this equation, it's just a straight line equation. So it should be by using y equals to mx plus c, or y minus y1 equals to mx minus x1. So it's up to you. Either you can use the first equation or the second equation. But first, you got to figure out what's the m and what's the coordinate. You need the gradient and the coordinate to form the equation. So the gradient will be just sine t. This one will be your m. And what about the coordinate? The coordinates are in terms of t. So the x and y coordinates are given here in terms of t. So we'll make use of these two coordinates and this gradient to form the equation. So let's have a look at the part 2 here. Let me jot down the coordinate. X should be equals to 1 over cos cube t. Y is equals to tangent cube t. The gradient is equals to sine t. So let's say now we substitute it into the y minus y1 equals to m x minus x1's equation. What we have here is y minus tangent cube t equals to the gradient is sine t times x minus the coordinate of the x is 1 over cos cube t. That's how we form the equation of the tangent. But then the question asks to express the final answer in this form. Y equals to x sine t minus tangent t. So we need to rearrange our equation. So y equals to x sine t minus sine t over cos cube t plus tangent cube t. So notice that the first part, the y is already arranged into the left hand side, and the first term at the right hand side, x sine t, is the same. So what we need to do now is just rearrange this part the same as tangent t. Okay, so let me jot down the x sine t and the y. So what we need to do now is change the tangent into sine cube t over cos cube t. And then you can combine the fractions and make it into a single fraction. So the denominator now is cos cube t, and the numerator is sine t minus sine cube t. And how to change it into tangent? We will just need to simplify it. The upper part, we will need to factorize the sine t. So it will be left with 1 minus sine square t in the bracket. And what is 1 minus sine square t? It should be equal to cos square t. So for now, we just can cancel off the cos square with the cos cube at the bottom, which means what we have here will be just sine t over cos t, which is tangent t. That's how we prove to the equation of the tangent in part 2. And that's all for the lesson today. Thanks for watching.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.